from Montreal, Canada. This is a talk which will be shifting focus or going back in time quite a bit. So we're going to be talking about connecting the past, looking at the past and the present, and seeing how information from the past can help us understand hazardous weather events using citizen science. So I'll be talking about some citizen science projects, mostly based on the Canadian chapter of ACRE, which is the Atmospheric Circulation Reconstructions Over the Earth project, and also the DRAW project, which is Data Rescue, Archives and Weather project run out of McGill University. And Renee Sieber is also a co-author on this presentation.
Victoria, I'm having some trouble with your audio.
Okay, can you hear me now?
Yes, now
yes.
I can hear you.
Okay, there was a little video that I was going to try and show, but I think the video cuts off the audio, so I will just not play it. So here's a few examples of transcription-based citizen science. One of them is on your left is the Old Weather, which is one of the first projects from the Zooniverse citizen science stable of projects back from 2010. So Zooniverse is I assume most of you know what Zooniverse is, but it's a stable of citizen science-based projects, which is run out of Cambridge University, where people can sign up to have a citizen science project sort of kind of organized for them by a team at Cambridge. So Old Weather was a project to try and, or not to try, it was a hugely successful project that succeeded in transcribing ship's logs in order to get more information about ocean weather, especially in the early 20th century. And recently they've had some projects to get information from the Arctic oceans to get more information about early sea ice conditions and information from the oceans, where meteorological data is very sparse. And on the right, we have the DRAW project, which is the project we're running out of McGill to get information on the McGill Observatory data. The McGill Observatory ran from was founded in the 1860s, and the information that we're trying to transcribe is from 1874 to about 1963. So the project, the idea behind web-based transcription projects is to get the information, collect the information from images that are put onto the web and then put into databases. And the information that is collected from historical transcription projects is then put into international databases and is often uploaded into reanalyses projects like the NOAA 20th Century Reanalysis Project to get global pictures of what the past weather was like.
Victoria, your audio dropped again, at least for me, and it looks like you're muted. Now it's back again.
Okay, so every time I change slides, it seems to mute, so I'll have to try and make sure I unmute. Okay, so one of the things that's very important for us in citizen science is to make sure it's a two-way communication. So we're asking a lot of our citizen scientists to transcribe handwritten historical documents. And we want to make sure that we put the information that we're giving them in context. So we have a number of channels to communicate with them and to give the information information back to them. So we have social media, we have blog posts, and we have Educator's Corner. We've partnered with several educational institutes and classrooms where we have curriculum that we bring into classrooms where we have students pick some dates, transcribe some data, and then look at look for resources around the time of the dates that they're transcribing to see not only how the weather impacted the society at the time they were transcribing, but also what the society was like, and what the infrastructure was like, and how things were different, how things were the same, and how things were different from what they're like today. And sometimes we have students write a blog post, or we have the teachers write a blog post, or something like that, so that their experience with using draw and using transcribing weather information can then come back into the community, and they can reflect on what their experience was like. Okay, so I realize this is a very different way of thinking about things. So why am I here talking to you about historical crowdsourced transcription to HIWeather and HIWeather citizen science? Like, why is this important to high impact weather? Well, one of the things I've been listening into to a lot of the very interesting seminars over the past month, and again I've been hearing that there's not always enough information. And this is something we find also when we're looking at climatology, and we're looking at hazardous weather, and we're looking at how to analyze climate and high impact and hazardous weather events, is we need more information. Thankfully, hazardous weather events tend to be rare. Because they're rare, or extreme events also by their nature tend to be rare, and high impact events, that means that we don't have a lot of instances of them. In order to get more information, in order to get more instances, we need to have more observations. One way of doing that is to go into the past and to get observations from the past, so we can have a larger data set and more observations. To do this, we need to look at the original observations. It's not enough to look at the daily means or the monthly means, which tend to be the observations that are compiled or that we tend to have readily available. We need to look at what we call the sub-daily observations, which is when people were keeping the original observations every couple of hours when we're lucky, and writing down the original observations as they were taking place, because this is when we have the information as it was happening on things like storms, heat waves, cold spells. This is where we have the information we need on the high impact events. It's not in the mean information, and it's not necessarily in the daily temperatures or the minimax temperatures. It's in the original observations. So the more observations we have, the more case studies we have. And what's interesting too is when we go back to the original observations, there's often a lot of ancillary information which tells us about the social impacts, about the resilience or vulnerability, and how societies changed over time in their reactions to hazardous weather and high impact weather. Why we need citizen science, though, is because there's just so much information, and so much of it is in paper form. It's been estimated that there's something like 1 billion observations worldwide that we need to be what we call rescued. A lot of these observations, because they're the original observations, there's only one copy of them. One copy of them on paper somewhere in an archive. So there's just too much work to be done by an individual project, or even weather services, although weather services are doing an incredible job trying to get this information. So we need to turn to help from the crowd to make this huge back catalog of observations machine readable. So the example I'm going to present here today is on snowstorms. So one of the examples we have in trying to look at how to connect past weather with present weather is in the definition of a snowstorm. So in Canada, we have observations that go back to the 1700s, to the French regime. And it's ironic in a way, because when we look back at the early weather diaries, we can do content analysis, because people wrote things like snow and cold, continual snow, snow with high wind, snowstorm. So we can just go back and look at the observations and come up with a record of snowstorms by looking at the observations. So these snippets here are snippets from weather diaries going back early Canadian weather diaries that were transcribed through an Acre Canada citizen science project, where about 500,000 observations, or 500,000 individual pieces of information, both numerical and descriptive, were typed up by citizen scientists. So when we put them all together, we can have centuries worth of observations of snowstorms. So here on the left-hand side, we have a very quick overview of the days per year of snowstorms in Montreal from the early 19th century, from the citizen science transcriptions of the early weather diaries. And on the right-hand side, we have similar estimates of snowstorms in Montreal from synoptic observations. And you can see that even though they're coming from different sources, they're roughly comparable. We can see that we have the same order of magnitude, the same kind of information that we're getting on the number of snowstorms days per year from the two different sources. There is a big gap in the middle, though, and that's not because we don't have the observations, but because we don't have the observations in digital machine readable format. And that's what the DRAW project is, to ask citizen science contributions to help us turn the McGill Observatory records into analyzable data. So far, we have about 1 million, just short of 1 million observations transcribed from the McGill Observatory records. And we estimate there's somewhere between 5 to 10 million observations total from the McGill Observatory records. So, okay, so we have something like a rough estimate of something like snowstorm days, but we also need we also want to go a little bit more in depth and look at more things that might be of interest to citizens, like snowstorm severity. So how can we go more in depth and look at and take advantage of the information we have to look at something at more of a quantitative index? So last year, some undergraduate students at McGill took this as a project to look at, to see how they could take the McGill Observatory data from the late 1900s and compare it to the modern synoptic data. So they looked at the Lewis index from Cerruti and Decker, and starting with this, wanted to see if they could adapt it to variables that are in common over the last, say, 150, 200 years. So they were able to do this. They adapted it to what they call the daily winter severity index by taking variables that were in common over a long period of time, and came up with an index which you see as the black line. So they adapted the index, but it still doesn't tell us when a snowstorm occurred. It tells us how severe the weather is, but it doesn't identify a snowstorm. So once again, we had to go back and think about what is a snowstorm. So they looked at the social impacts. They went through media coverage, and they looked at things like when schools closed or when flights were canceled. And they came up with a threshold value, which was just over 1.5 on the severity index. And using that threshold value, they decided that anything above this threshold of 1.52, I think it was, would be defined as a snowstorm. And then they checked this by looking at the snowstorm warnings that were given out by Environment Canada, and they were happy with the results. So we had to find several different ways of defining what a snowstorm meant. And then they took this index and they took their threshold value and they used it to identify snowstorms in the McGill Observatory data that was compiled by citizen scientists for Januaries in the late 1800s, and found that there was no statistical difference in either the number of storms identified or in the severity of storms identified. So we were happy with that result because it showed that we were able to take modern synoptic data, we were able to take information from the McGill Observatory in the 19th century, and we were able to come up with similar results from these different types of information collected. So what can we say about this information? What were our sort of final findings from this? So first of all, we couldn't even start to do this kind of analysis or results of past weather if we did not have the citizen science contributions. So we need to have help from citizen scientists to transcribe this huge backlog of information. Once we do have these transcriptions, we can look at the historical weather records and combine them with the modern synoptic data to produce things like snowstorm series, which cover centuries. And here I'm looking at snowstorms, but we can also look at things like drought indices, like smoke indices to look at forest fires, and other indices for hazardous and high impact events that can go back for decades and centuries. These historical transcriptions also force us to think about concepts such as storm and even storm severity and even things like the definition of a storm. Can we come up with a definition of what a storm is that can transcend all these different types of observations? Something that can look at both the descriptive observations from the very early weather diaries all the way up to modern synoptic records. Because in the modern synoptic records, we don't write snowstorm. So we have to come up with some kind of definition that can stand through, can be resilient through all these different changes in observing systems. And then once we can do this, it's quite interesting to see that we don't find very significant trends in snowstorms. We did find some decadal scale variability. Some of the other hazardous indicators that I looked at did show some trends, blowing snow, a few others, but some of them didn't. So it's interesting to see. It might be more something that we need to look at things like variability rather than trends when we look at changes over time. Now, what do we see when we look at how this relates to citizen science? How can we think about citizen scientists when we incorporate them into our work or into our research? So one of the things that was very important to note is that citizen scientists are very much our collaborators. They made discoveries because they have the time that we don't always have to look at these pages and these records in detail. They become, in some ways, the expert on these. So they made discoveries in terms of weather categories and weather terms that we missed because we didn't have time to look through 10,000 pages, and they have time to look through the pages in detail. So it's important to note that that we have to trust in our citizen scientists, and they become their experts in their own right. So as part of that, they become educated in historical meteorology. It's also interesting to see that they find it in their own way relaxing and rewarding. So some of them say it's the equivalent of doing their daily Sudoku or daily crossword puzzle. It becomes very zen once they get into the zone of transcribing. So, but it's also something they find rewarding because it's something that they feel they're contributing to the larger scientific community. It's something that they feel they're contributing to finding out more about climate, finding out more about climate change, which is more the aim or the way they think about contributing to draw. But there's also we also try to explain that it's something to do with rare events and extreme events, which is why we have to go and transcribe the original subdaily records. So they also become engaged through the community because they learn more about the history by learning about the weather and the history of the weather. And they also make connections with the past and present weather conditions by looking at how the weather occurred in the past. They sort of tells a story about how the weather occurs in the present. So thank you for giving us a chance to talk about this here at HIWeather. We also want to thank the students who did the research onto the Storm Severity Index. A big thank you to all our citizen scientist transcribers because they're the ones who make this science possible. DRAW is a very interdisciplinary kind of project. I didn't get a chance to talk about this, but it goes between faculties and between departments at McGill. So we have colleagues in the School of Information Studies, Library and Archives, Atmospheric and Oceanic Sciences and Geography. So they work on this project as well. And also thank you to our funders in Canada, SSHRC and FQRNT. So I'll be happy to take any questions or discussion.
So thank you very much for your talk and the effort to extract more data for us from the past. I mean, as you showed, I think it's a treasure trove, and there's been all these documents lying in archives, probably in all our countries. So we do have already a question in the comments. So from Brian Golding, probably you can just unmute and go ahead.
Okay, thank you for your presentation, Liz. It's very interesting. And I guess you're to some extent working with an observatory record, which doesn't have some of the problems that I was concerned with. But all weather records often use instruments that were not exposed to modern standards. Some of the textual records are going to be subjective and dependent on the person actually making the record. Locations change, and that's not always recorded. And in any case, even if the location doesn't change, trees grow, there are new buildings, and so on. And so how do you deal with all these issues with these old records?
Yeah, there's a huge industry almost dealing with these records, with these issues. And there are even conferences devoted to homogenization issues. One of the things that's really quite interesting, I found, is when you have a large amounts of data, which you do with the sub-daily records, you can use a number of statistical techniques that you can't use because the data are not independent, but there are others that you can use. So I was really quite surprised when I looked at some of the earlier records and I did frequency analysis, for example, on the temperature records, to see how closely the records, the histograms of the temperatures, for example, adhered to the histograms of the records from the airport, the modern airport records, modern synoptic records. I could actually tell if the hour changed by looking at the hourly histograms from the synoptic record, the modern synoptic records, and comparing them to the histograms of the older records. I could tell. I mean, I could see when the hour of observation was. But you have to have enough. Obviously, to use this, you have to have enough observations. You can't use it if you just have 2 or 3 records. So that's one technique you can use to judge the reliability, for example. So it's good and it's bad in the sense that the more information you have, the more you can use statistical records. Another one is we're sort of looking into this. A lot of the people, again, it comes down to the same kind of question we have with a citizen scientist, like how much do you trust them? And a lot of the people who were keeping the records were really very interested in doing this. They spent a lot of time, a lot of effort, a lot of money on their instruments. And the more we look into the background of the people, the more if we're lucky enough to find the records, we find letters, we find networks, we find receipts for their instruments. So of course, there will be problems, but we also have problems with our modern observations. I think we all know that our modern observations aren't perfect either. So it's really a question of trying to identify them and trying to compensate for them, and as much as we'd also try to compensate for the problems in our modern records. So it's a question of trying to balance out the problems and the biases of the relative records. I don't know if that answers your question.
Thank you.
So, Victoria, another question I would have is, So we all have this kind of data lying around somewhere. Is there some template for an application to gather that data via crowdsourcing? I mean, is there some kind of boilerplate approach, some standard thing that you could recommend that people can look into when they want to do that for an old data set?
Well, we have published on our tech on what we've been doing, and our template is available on GitHub. There's some people, as I mentioned, their old weather and others have gone on to Zooniverse. So there are some projects that have gone to Zooniverse. It depends a lot on what kind of data you have and your funding, and what your resources are. We're trying to move. What we're trying to do with Draw is to develop a way of making it traceable and transparent. So in the past, what people have done is sort of have their documents, and maybe so we're moving more now towards having image files of the documents, and then having a spreadsheet. So typing things up into a spreadsheet, and we're trying to move away from that and to type things up directly into a database, so that we don't have all these different files. We sort of have you sort of have your original record, and you have an image file, and then you have a spreadsheet, and then you have to put it into then you have verification files, and then you have a database somewhere. So we're trying to move away from having all these steps and move more towards having typing things up directly into a database, which is why we developed the web app, the Draw web app, which I showed at the beginning, to make it more traceable. We don't want to have, especially because a lot of the projects, unless you're a big organization, these are going to be small projects, and people will be coming and going if you have students or if you have a citizen scientists. So there needs to be a way of being able to track what you're doing. And there's also not a lot of money in this. So again, it's going to be probably something that stops and starts. Maybe you'll start a project and have some money, and then it'll run out of money, or you'll have volunteers. So there needs to be a way of being able to track what you're doing and trace all the information back. So so we've been trying to develop that with Draw. Again, you can also look to Zooniverse. We're trying very much. So there's the atmospheric circulation reconstructions over the Earth. That's a group of us who are working in historical reconstructions, and we're trying to come up with templates, and we're trying to come up with procedures to do this. But again, it's very shoestring. But yes, we can try to talk about this and guide you through.
Yeah, that sounds like a pretty good starting point. Nice recommendation. There's also some comments in the chat on that topic, but I think we have now 5 UTC. So I guess we can close this session officially.